Now we'll discuss chapter 4, heat. So first of all, what do you mean by heat? Heat is energy which indicates whether if an object is hot or cold. How do we know that whether if this object is hot or cold? So that's why we use a physical quantity known as temperature. So a reliable measure of measuring the hotness or coldness of an object is known as temperature. Now we'll study about measuring temperature in detail. We all know that suppose when we have fever, we check our body temperature using a thermometer. So this thermometer, which is used for checking our body temperatures, is known as clinical thermometer. So what does this clinical thermometer consist of? It consists of a long, narrow, uniform glass tube. And it has a bulb on one end which is filled with the liquid metal known as mercury. Why it is filled with mercury? Because mercury is very useful. Mercury easily expands upon heating and it's very clearly visible, and it expands on a very uniform basis, and since its density is much more than water, it can occupy less space as compared to water. So that's why mercury is the best element suited for thermometers most of the time. However, there are other thermometers like alcohol thermometers as well that we will study later on. A very useful property of mercury is that mercury expands on heating and shows the reading very clearly. So the scale which is marked on the thermometer, mercury expands and shows the reading clearly. Or nowadays even clinical thermometers are digitalized. We have electronic circuits, we have digital readings. So the exact reading is shown by the digital thermometer. However, the function of mercury remains the same. And there are 3 units of temperature which is used widely all over the world. The SI unit of temperature is Kelvin, capital K. However, we also use degree Celsius or centigrade, which is degree C. And we also use degree Fahrenheit or degree F. Widely we use these 3 scales of measuring temperature all over the world. And we all might have heard about our normal body temperature, because we are warm-blooded animals, because we are mammals. So our body has to maintain a constant temperature always. So that's why our normal body temperature, or in general the normal human body temperature, is equal to 37 degrees Celsius or 98.4 degrees Fahrenheit. Slight variations are allowed, but however if the variation is too much, we tend to have fever and we become ill. And apart from this clinical thermometers, a lot of laboratory thermometers are used as well extensively all over the world, in industries, in various laboratories for various experiments. The principle of measuring temperature is the same. However, a few points should be properly taken care of when you are using laboratory thermometers or simply lab thermometers. Mainly the lab thermometer should be always kept upright or in a straight manner, which is normal to the vessel or the container, and it should not be tilted, and it should be surrounded by all sides by the liquid which is to be measured. That's why these 2 points has to be properly taken care of. Now we'll study this topic, transfer of heat. So there are mainly 3 ways of heat transfer which occurs all over the universe. So the first mode of transfer of heat or heat transfer is conduction, which normally occurs in solids generally. For example, if you take a metal rod and if you heat it on one end by a candle, and if you keep holding it for some time, if you touch the other end of the metal rod, you will find that other end also to be hot. Why? Because the heat has been transferred through the solid by using conduction. So that's why conduction is the process of heat transfer in solids in generally, because the particles inside the solid, they vibrate and they transfer the heat in the form of waves. So and then you have 2 important terms to be noted down here, conductors and insulators. So what are conductors and what are insulators? Conductors are substances which allow heat easily to pass through them, and insulators are substances which does not allow heat to easily pass through them. Good conductors of heat are almost all metals like iron, copper, aluminium, etc. And good insulators are for example wood, plastic, etc. This is a very common mode of heat transfer, conduction, which we come across in our everyday lives. Now we'll move on to convection. Convection is the other mode of heat transfer which normally occurs in liquids in generally. What happens is, when you heat the liquid near the heat source gets hot and rises up. Then the air from the sides comes in to take its place, and then the entire liquid is heated. So for example, boiling the tea. So Initially the liquid is cool, but after heating some time, the entire tea is boiled by using the process of convection. Because the liquid which is near the heat source, it gets hot and it rises up, and then the liquids from the surrounding areas of the vessel comes in and takes its place, and in this way the entire liquid is heated. And then we'll study about a very good application of convection. The two very good applications of convection are sea breeze and land breeze. So what do you mean by sea breeze and land breeze? Sea breeze is air which comes from sea towards land, and land breeze is the air which comes from land towards sea. So this is a very good application of convection. And then we have the third way of heat transfer, which is known as radiation. Radiation does not require any medium to transfer. It transfers heat without any medium. It can also transfer heat in vacuum or in space in general. For example, the sun's rays which we receive on our earth daily, that is traveling from a huge distance through space without any medium. So this is an example of radiation. And also, suppose if you're in a room and you have turned on the room heater, so the heat obtained from the room heater, it's also an example of radiation. And then suppose you have a hot vessel or a hot utensil, like for example the boiling tea vessel which you have kept it for cooling down. After some time the heat is dissipated to its surroundings in the form of radiation. So cooling down of a hot utensil is also an example of radiation. There's a very important note to be noted down here. The note is, all hot bodies radiate heat. All hot bodies radiate heat. A part of the heat is absorbed and a part of it is reflected generally. So this is the general pattern of absorption and reflection of heat. Okay, we'll discuss this topic. Kinds of clothes we wear in summer and winter. So normally we wear light colored clothes in summer and dark colored clothes in winter. For example, we wear cotton clothes in summer and woolen clothes in winter. I mean, the reason for this is cotton clothes, they reflect more heat and helps us stay more cool during the summer. And the woolen clothes or dark colored clothes, they absorb more heat and helps us to stay warm during winter. And then there's a very important application of the trapping of heat. For example, if you have one thick blanket or two thin blankets, so in which one you will get more warmth or heat? Obviously you'll have two thin blankets will have more warmth. Two thin blankets are warmer than one single blanket due to a layer of warm air trapped in between the blankets. So that's why this is more convenient. Instead of putting one thick blanket, if you put two thin blankets, that will be more warmer than the one thick blanket which you're using during cold seasons, normally during winters. So this is a very good application of reflection and absorption of heat. So in this way we discussed a lot of wonderful topics in this chapter 4, heat. You can also do some Google search and learn more and more about this topic, heat. And if you have any doubts or suggestions, you can let us know in the comment section below. Thank you so much. Have a great day.